Perjalanan Fakultas Teknik dimulai sejak tahun 2000 dan kini telah memiliki 5 program studi, yaitu Teknik Elektro, Teknik Sipil, Teknik Geologi, Teknik Informatika, dan Teknik Industri. Selama perkuliahan, mahasiswa juga dibekali dengan kemampuan teknis melalui kerjasama magang atau kerja praktek dengan berbagai perusahaan pemerintah maupun swasta dengan harapan membekali lulusan dengan kompetensi yang baik. Profil lulusan Fakultas Teknik bekerja di berbagai sektor industri, instansi pemerintah, swasta, NGO, entrepreneur, bidang akademik seperti guru dan dosen, dan berbagai bidang lain. Dalam bidang akademik, sivitas akademik Fakultas Teknik turut serta berperan dalam mengembangkan masyarakat melalui berbagai program penelitian dan pengabdian kepada masyarakat. Selain di bidang akademik, Fakultas Teknik juga memberikan ruang untuk mahasiswa mengasah minat, bakat, dan penalaran melalui berbagai organisasi dan unit kegiatan mahasiswa, sehingga mahasiswa bisa berprestasi dalam bidang akademik maupun non-akademik. Dengan kualitas pendidikan dan fasilitas, serta kerjasama yang baik dari seluruh sivitas akademik Fakultas Teknik Universitas Jenderal Sudirman, kesuksesan dan masa depan yang cerah dapat diraih oleh putra-putri terbaik dari seluruh Indonesia.
Good afternoon, distinguished guests, ladies and gentlemen. Thank you for joining us again. Ladies and gentlemen, we are now continuing our meeting to the next agenda, that is the second panel session, which will be delivered by our invited speakers. Dr. Insinyur Heru Dewanto, ST MSc Engineering from Institution of Engineer Indonesia. Professor David P. Watling from University of Leeds, UK. Professor Silvio Ranise from Fondazione Bruno Kessler, Italy. This session will be guided by moderator Mrs. Swahesti Puspita Rahayu Eskom NT from Informatics Engineering of Universitas Jenderal Sudirman. Ladies and gentlemen, please welcome our keynote speakers and moderator.
Wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to the second plenary session of the International Conference of Engineering, Technology and Innovative Research 2021. My name is Swahesti Puspita Rahayu. It's an honor to me to be the moderator of this session. Thank you all for joining us, especially for our three distinguished speakers that will share their speech in this session. They are Dr. Insinyur Heru Dewanto, STM Master of Science and Engineer. He's the president of the PII, or Association of Indonesia's Engineer. And then Professor David P. Watling, he's the Centenary Professor of Transport Analysis from University of Leeds, United Kingdom. And Professor Silvio Ranise, Director of the Center for Cybersecurity at Fondazione Bruno Kessler, and he's also Professor at the Department of Mathematics, University of Trento, Italy. This plenary session will be divided into two parts. The first one is where the keynote speaker delivers the speech, and after that we have the discussion. We have about 25 minutes for each speech. Now let's start with our first speaker. I will read his CV shortly. Dr. Insinyur Heru Dewanto, ST, Master of Science and Engineer. He is the President of the PII, Persatuan Insinyur Indonesia, Chairman, Asian Federation Engineering Organization. He is also the President of Association of Engineering Education in Southeast and East Asia and the Pacific. For working experience, he's been the CEO, board member, and the general director of some companies, including PT Pembangunan Saranajaya, Indika Power, Cirebon Power Services, and Cirebon Energi Prasarana. Are you ready, Dr. Heru? How are you this afternoon, sir?
I'm good, thank you so much.
How's Jakarta? Safe and sound, I hope.
Can I start or do I have to wait?
Yes. Ladies and gentlemen, please welcome Dr. Heru Dewanto.
Thank you so much. Can you hear my voice?
Yes.
Clearly?
Loud and clear. Yes.
Okay, Excellencies, distinguished guests, ladies and gentlemen, a very good afternoon to all of you. It is truly a privilege, an honor for me to be able to speak and share our view concerning how the global engineers collaboration should be organized in achieving the Sustainable Development Goals. So let me start with this book. To answer the question whether human civilization is actually making the world a better place to live, the answer according to Steven Pinker, is that this is the best time in human history to be alive. Why? Because we have more disposable income, we are smarter, we live longer, safer, freer, and richer. The birth rate are falling, and the nature is rebounding. So even the last century richest and most powerful emperor could not imagine the comfort and the wealth that we enjoy today. This is the greatest innovation of mankind that makes us live so comfortably as we enjoy today. So engineers has played an important role in shaping human civilization across the history of mankind. Engineers has brought us to enter into society 1.0, hunters and gatherers, and then agriculture technologies has brought the human civilization to enter society 2.0, and then we know that the invention by James Watt brought our civilization to enter society 3.0, and then society 4.0, and now we are preparing ourselves to enter into the realization of society 5.0. Now, as consumption of global population on engineers' innovation and invention sky high rises, they entail residues that become global problems as we face today. The question is, who will save the world? As engineers has helped, can you come back to the, as engineers has helped to shape the civilization along the history, we engineers become also responsible to solve the current and future global problems. And to achieve SDG 2030, which is the world blueprint for building a future of peace and prosperity for all. So it is SDG 2030 is our global common goal, and all the 17 goals will require engineering solution. So how engineers can mobilize ourselves to save the world? First of all, we need a global engineers collaboration. A global engineers collaboration will need an equivalent standards. And today we have two standards. The first is engineering education standards, and the second is competence standard. For both, we have multilateral agreement. For engineering education, we have Washington Accord, Sydney Accord, Dublin Accord, and also Seoul Accord. For competence standard, we have multilateral agreement, including among others is the APEC Engineering Register. Universality of engineering discipline will require a global engineering system that allowing us to collaborate and mobilize our expertise as engineers. So this is the multilateral agreements that facilitates for both standards. The first is the education standard, which is the OBE Education Accords, and the second is competence recognition multilateral agreement. Washington Accord, Sydney Accord, Dublin Accord for engineers, technologists, and technicians. And also we have International Professional Engineers Agreement for engineers, technologists, technicians, and also APEC Engineers Register. Now, let's see Indonesia. Indonesia is not only beautiful with its natural treasures, but it also offers many challenges. And no country is more challenging than Indonesia, at least from engineering perspective. Indonesian engineers are facing a much bigger challenge compared to engineers from any other countries. There is no country like Indonesia. So Indonesian engineers has to unite the nation, to unite 17,500 islands across the archipelago of Indonesia. Indonesian engineers also need and have to meet the minds and hearts of 168 million population that consists of 1,340 ethnics and 742 languages. This is why I said that without engineers, there is no united Indonesia. For that reason, it is very important for Indonesian engineers to be systemized, and a new system and infrastructure need to be in place in Indonesia with the mandate from the regulation, from the engineering laws and the government regulation issued in 2019. For the last 2.5 years, the Institution of Engineers Indonesia has transformed our system and infrastructures, the engineering system and infrastructures. Starting from engineering education, engineering profession education, professional engineer competence, international recognition, and registration and database development. Across the value chain of engineering, the Institution of Engineers Indonesia has transformed our system and infrastructure for engineering arrangement in Indonesia. And today, engineering system and infrastructure in Indonesia is compatible and become part of the global engineering system and infrastructure. Now, we are talking about the number of study program which are accredited under the international accreditation. We have 2,500 study program in the whole country. And as of today, there are only 57 study program being internationally accredited by PII, the Institution of Engineers Indonesia. Our journey is still long. We need to accredit the remaining 2,500 study program in Indonesia. If we are talking about the competence accreditation or competence certification, today to 900,000 of practicing engineers in Indonesia, we only have like 20,000 certified PE professional engineers. Again, our journey is still a long way to go, but however, we have started and quite quickly catching up with the progress that we made until today. Now, when we are talking, come back to the multilateral agreement, which is basically governed under the economic treaty. The engineers' mobility is actually the ultimate goals of multilateral agreement on mutual recognition under any of economic treaty, including APEC, AFTA, and others. However, due to the pandemic, there is a significant reduction of mobility of profession due to restriction imposed by many governments. There are three phases of mobility in 2020. The first is the lockdown from January to May 2020, and then a phase reopening from June to September 2020. And the third phase is actually response to new outbreaks and virus mutation, which is happened from October to December 2020. Indonesia just recently experienced the second or perhaps the third wave of the pandemic, and we still relaxing the lockdown that we have to experience for the last few months. Now we can see that mobility is changing. The physical engineering mobility under multilateral agreement continue to face various obstacles. The data shows how visit to places such as to workplaces, public transport, and almost in every sectors basically facing a very significant reduction in mobility. The advancement of IT accelerated by pandemic has reduced the global mobility quite significantly. As such, virtual collaboration become a new normal in mobility. So how we see and engineer the future of engineering collaboration? So we believe that collaborative platform is a must. So now a survey by a collaborative platform company shows that almost 80% of users say that their collaboration platform is very important to their work. 78% say they will continue to use available collaborative platform even when normal work routines resume following the pandemic. 100% of users want to keep using the collaborative platform even after the pandemic, citing it's important in collaborating at any time that works best for them. So the data shows a clear trend towards collaboration platform as a new norm. We can see also the increase of collaborative software usage everywhere. The percentage of employees working from home in North America stood at almost 80% as of December 2020, only dropped 5% from its mid-March peak. In Asia Pacific and China, which have had continued success in controlling the spread of the virus and preventing the resurgence, 64% of employees were working from home as of 20 December 2020. Usage of nearly all collaboration tools increased substantially, except for Skype for business. Microsoft Teams experienced the highest growth, around 3,891%. Zoom was the second, 1,788%, followed by Slack and WebEx at 1,000%. Now we can see that the physical mobility basically curtailed. Then the economic treaty related to multilateral agreement need a new proposal rather than only talking about physical mobility of engineers. We believe that engineering multilateral agreement should not only focus on mobility, which is the very basic idea of economic treaty, because it's turned out that the pandemic has significantly reduced physical mobility and geographical boundaries are no longer applied. On the other hand, engineers are badly needed to solve global issues to achieve SDGs 2030. We believe that critical role of multilateral agreement under any economic treaty should be now more towards achieving SDGs. For that, the role of mutual recognition becomes essential. The multilateral agreement has built an equality and mutual platform. However, it needs to be encouraged with more concrete steps of collaboration among world engineers in the framework of SDGs. The Institution of Engineers Indonesia, PII, currently developed a digital platform for professional engineer certification and registration in Indonesia. This registered PE database is projected to link up with national certification for a certain occupational competency in according to relevant sectors, as well as to link up with regional professional engineer registration database in ASEAN, as well as in APEC jurisdiction. So if each country does the same, imagine what we can achieve when engineers around the globe with equivalent standards are collaborating through a global collaborative digital platform in solving each of the global issues and shaping the society 5.0. The digital platform for global engineering collaboration basically aim to promote how we can collaborate and refocus our mobility of engineers beyond mobility into promoting a global collaboration to solve global issues and to achieve SDG 2030. This collaborative platform will extend professional competence standard globally, build talent pool of selected global engineers with advanced skill, innovation, project portfolio, working experience, who meet engineering education standards and professional competence standards. It also be able to build a quad helix orchestrator with industry, government, academic, and PE community. Ladies and gentlemen, this is our view from Indonesian engineers institutions, and we believe such a collaborative platform should be developed to be able to accommodate collaboration of all engineers across the globe so that we can work together to solve common and future global issues, which actually the residues of our innovation and creation. Thank you so much and good afternoon.
We continue to our next speaker, Professor David P. Watling. He's a centenary professor of transport analysis from University of Leeds, United Kingdom. He's also an editor for some highly respected journals in transportation, founder and program committee in numerous international conferences. His expertise area includes mathematical modeling, simulation, statistical analysis, and optimization of transport systems, transport networks, visioning of future systems, and dynamic processes. Professor Watling, are you ready?
Yes, I am. Can you hear me okay?
Good afternoon, sir. How are you?
Can you hear me?
Yes, perfectly. Okay, ladies and gentlemen,
good.
Please welcome Professor Watling.
And I believe someone else is going to share my slides. Is that right?
Yes, we will share your slide, Professor Badling, in a couple of minutes.
Okay, thank you.
Mhm.
Okay, thank you. Can everyone see the slides? Okay.
Yes, we can see your slide. That's
Okay, and
perfect.
if I
Yep.
want, if I want to change, I just say next slide. Is that right? Or can I change it? I'll just say next slide, shall I?
Next slide, please.
Yeah. Okay. So thank you very much for inviting me to this conference, and that was a really interesting presentation to open the conference. My particular talk is going to be looking at one aspect of engineering, transport engineering, but I'm going to be looking at an issue that really is of interest, I think, across many aspects of this conference, which is the question of what's usually referred to as big data. So I'd seen this term big data used by many people, and I was kind of interested to know, well, what does it mean? What does it really mean? Does it just mean that we have more data, a bigger sample size, or is there something more important going on? And I started conversations with many people, and as a result, with a colleague, David Milne, we ended up writing a paper a couple of years ago. Interesting, this was before the pandemic, but I think it's also interesting as I go through my presentation to think about the relevance of what we said now, having lived through the last year and a half of very different circumstances. So I think a lot of what we said in there has particular relevance to what we've just been living through. So mainly the presentation is meant to be a think piece. So really to make you, to stimulate discussion, and I'd be interested to know other people's opinions on what I say. There's also some examples of applications at the end I'll present briefly, and that's based on collaborations with several other people. And there are many references given at the end if you want to know any more. Go to the next slide, please. So the context behind what I'm talking about is what we've seen in the last 20, 30 years is a big technological advance, both in how we collect data, how we capture it, but also how we store it. We've seen a big change in how we can monitor human behavior, how we can monitor the physical world, and how we can actually track and connect together, triangulate different data sets. So we can match together different data sets to see what aspects they tell us about the same circumstances. At the same time, the real world has changed. And this, I wrote this before the pandemic. Is that just for me? There seems to be a grey square that's just appeared in front of my slide. That's good, yeah. So Sorry, can you go back, please?
Balik. Back.
Right, that's good, yeah. So we've seen a big change in how people actually behave. And I say, I wrote this before the pandemic. We talk about how in the last 20 years, people plan their movements differently, how we network socially, and how we give details for all sorts of different transactions. But now during this last 18 months, we've seen a significant and possibly long-lasting change in how we're going to use technology, how we substitute non-travel for travel, such as this conference, and how we monitor behaviour, how we track potential contacts for COVID, and how we've given data to be given passes to be allowed access to things. So there's a lot that's going on, and it's been increasing in speed in the last 18 months, I would say. Next slide.
Next.
Please.
Next slide, please.
So what this means is we've had this rapid growth in digitized data and data that I call non-purpose oriented. So it didn't have a particular purpose at the time, or its purpose is different to what it's being used for now. So what I mean is we have a large increasing availability of data that either was not specifically captured for transport application I'm interested in, but have relevance to it, or have been archived to preserve historical pictures, historical trends of transport patterns, but without necessarily having any method to analyze these archives. Next slide.
Next slide.
So this method can be said to completely contradict the classical method of statistical inference. That's my subject. In statistics, as I was taught it when I was learning, we start off by designing an experiment. We sample randomly and we decide what data we need to collect before we actually collect it. So big data has turned this completely around. So some claim this is contradicting even the scientific method. I think this is a quite extreme claim, but it's something big is definitely happening. So the real question I had in my mind is what? And it seems more than just the data sets being very large. So big data seems more than just big. Next slide, please. So the motivation is to try to identify what is truly special about big data from the particular perspective of transport planning, and to actually hopefully by that provoke some debate. So if you don't agree with what I've said, that's fine, but I wanted to start people discussing this. And while doing that, to identify some promising areas for future research and real life application. Next slide. So as I said before, I'm not a data science specialist. I was a statistician originally, and I spent my life as a transport modeler. So I'm trying to understand, as a transport modeler, what big data can offer me. A particular point I would make is my focus will be on medium-term transport planning, not on providing real-time information for control. I think that is quite a different issue to what I'm talking about. So I'm talking about planning transport systems over a period of years and how we might think about doing that. Next slide, please. So based on that, we came up with some what we called big questions for big data. And I'm going to try and answer at least some of these during the presentation. But I think these are questions that we could ask. So particularly I'm going to ask, well, what is big data in the sense of transport planning? What new opportunities could it provide for transport planning? Or what difficulties does it give? What need to be overcome? How might we need to find new ways of analysing transport data? How might it affect the real transport systems? How might predictive transport models change as opposed to the data analysis techniques? And therefore, how might transport planning even change as a result? And through that, it's provoking the idea of what are the important directions for future transport research, but also for transport planning practice. Okay, that's quite ambitious to answer all those 9 questions, but I'm really just saying those are in my mind as I'm talking. So these are just questions to have in your mind that I'm going to try to at least touch on during my presentation. Okay, next slide, please. So what is big data? So I'm not the first person to talk about big data, and if you look at the literature, many people have tried to characterize in general, what does it mean? These are some definitions that I've found in the literature, and I'm writing them here just to show you that they exist, but I don't really find them that useful. I mean, there are parts of them that I think are interesting, but some of them relate to the ones that I've called them 3V, that this is just my maths side doing this, that people talk about different aspects of the data. So volume meaning the quantity of data, velocity meaning how quickly you can collect them, so how often you collect them, and variety meaning what diverse kinds of data you can get. But other authors have talked about the relational nature of data, how different data relates to one another, how you can triangulate it. And others have even talked about, as Anderson mentioned, the end of theory. This is really quite an extreme view, but quite an interesting document to read. So many people have talked about what could big data mean. I'm not going to try and find one definition, but I'm going to talk about some interesting aspects, useful aspects, I think, for the application I'm interested in of transport planning. Next slide. So I think one particularly interesting feature, and I think this is an interesting feature, particularly given the last 18 months, is the idea that we have continuous monitoring. So potentially we have systems that are monitoring, that have detectors that are monitoring perhaps traffic movements, passenger flows, aspects such as that all the time, and potentially storing them. It depends on the storage capabilities, but potentially storing these historical patterns as far back in time as the database was started and the storage allows. What this means is that we're not constrained to decide in advance what we need to analyze. We can look back in time and, for example, look at how transport or traffic counts in a city have changed over the last 10 years. If we only look at, say, January, or we only look at September the 1st, going back 10 years, how has it changed both before the pandemic and during it? So we have this comparative database. So that's one important aspect. Next slide, please. Next slide, please. Thanks. A second important feature is the fact that the data itself might not actually be owned by the person analysing the data and might not have been designed for the purpose. So we see commonly people use public transport ticketing data that originally was just for revenue purposes. One of probably the most well-used kind of big data is mobile phone data. But what we've seen is that as initially this data is provided relatively freely, but then as data providers see there's a market for their data, they can make a profit out of it, then the access to the data changes. And it may no longer be economically viable to use this data. And there's also been a lot of data reuse as well, so this is also another aspect of it. Next slide, please. I think another feature of big data in transport is the fact that in the past there's been a relative paucity. There's been relatively little research using statistical techniques to understand transport. I'm not saying there's been none, but there's been quite a small fraction of it as looked at that. And often that can be the difficulty in obtaining the amount of data needed, particularly if we're looking at travel patterns, such as where people go from and where they go to, the origin to destination movements. This has always been a very costly bit of data to collect, and so asking for repeated data on this was not feasible. It was too costly. Now we have potentially enough data to start applying better statistical techniques. So the way we analyze data can therefore change. Okay, next slide, please. I think the final thing I would mention about big data in transport planning is we can actually start using data sources outside transport as currently studied. So that provides the opportunity to find new explanatory variables, new things that explain how transport varies, that is beyond the current knowledge or wasn't previously quantifiable. So people apply data mining methods and to data sources such as data from fitness watches or from other sources that aren't transport data. So this allows us to potentially challenge existing theories and hypothesize new ones. So we can talk about how travel might occur and actually test those theories with these new kinds of data. I think a second aspect of this final slide on what is big data is this idea of linking different data sources that are contemporaneous, that were taken at the same time. So this allows you to triangulate different data sets, and because they overlap in time, you may be able to decide how, say, some census data, traffic flow data, ticketing data, if you take them all together, they provide a much better, richer picture of what is going on. And this could be at different levels of aggregation, from an individual to some higher level of aggregation, either spatially or in terms of the population. Okay, so those slides were asking, firstly, what is big data in terms of transport planning? Next slide, please. And one organisation that specifically asked this in general about, not just about transport, but talking about these new kinds of data on what was called the human condition, is the OECD. The examples they give in their report have example applications in transport. So there are references in the paper I gave to people who've used all these kinds of data for understanding transport. So whether it's data from government transactions to do with tax or social security, I guess it could now be to do with some sort of vaccine registration as well, or other aspects like that. Data related to official registration or licensing, perhaps for vehicle use, commercial transactions by individuals and organisations, such as credit card data, internet data from search and social network activities, so people have analysed Twitter data, other kinds of social media, tracking data such as GPS, been widely used, and image data such as that from satellite images, but also from video images on land. And as well as this, there's there's not only data on the human condition, there's relevance of data on physical elements, such as the conditions of the rail tracks or emission levels, information from IoT devices, for example. Okay, next slide. Okay, so we've talked a bit about what is big data, or what might big data mean for transport planning, but what new opportunities then does it provide? So the first opportunity I'm suggesting is that we might be able to analyze data at a more raw level. So often we found an example of what I mean by this is when we traditionally collect traffic flow data from inductive loops, we need to use mechanisms which are effectively models to convert loop data to vehicle counts. Perhaps now we have the opportunity to observe vehicle trajectories in a more raw form, where we do not have to add these extra unknown, uncertain elements to convert the data to the form we need it in. A second advantage, and I think this is especially relevant, is the fact that continuous monitoring allows us to study new kinds of variation. Whether that's by time of day, between days, different times of year, seasonal effects, or something to do with some scenarios. To correlate with data on events or weather, or as we found out, pandemics, and to monitor unexpected events. So in the past, people have been able to use this to monitor disasters such as the Fukushima disaster in Japan and the bridge collapse in America. So because there was this continuous monitoring going on, even before the events occurred, there was a baseline to compare against. A third potential benefit of big data is that we have this opportunity for a finer disaggregation of effects. In principle, this gives us the opportunity to study small or disadvantaged groups, because the sample size for those small groups will be sufficiently large that we can infer something about them. So even though a small group of people, even though a group might be small in the population, the data is large enough that we can actually understand something about them. In transport, there's a very wide dependence on stated preference. So this is a technique for understand how people would behave in hypothetical circumstances. So how would people behave if you changed, you made some policy change? But this is a hypothetical situation, not how people behave, necessarily how people behave in real life. So I think big data might mean we have to depend less on stated preference. We get more real data, more revealed data, because we're observing people, individuals, in a variety of contexts. And potentially also an important aspect is obtaining information on non-chosen options. So when you're trying to understand how people behave, it's also interesting to know why they didn't choose some travel options as well as they did choose some. And potentially, eventually, to find behavioural models that are transferable perhaps across different regions and across different contexts. Okay, next slide, please. Clearly, there's many technical, analytical and computational issues with big data simply because of its size, but huge advances are being made in techniques such as machine learning and data science. But one issue that we have to have in mind is how do we future-proof our methods if there's no guarantee that we can have access to the same data in the future? For example, if we don't own the data, what happens if we come up with a method and we need this externally provided data, but the external providers either don't provide the data or provide it at too high a cost for us to afford? And the biggest issue, perhaps, a very common issue to overcome, is the issue of privacy. and how we trade off the quality of the data in terms of its fidelity, how much information it gives us against privacy. So this has been a big issue with providing mobile phone data. So often it's aggregated to preserve privacy, but then you don't get the same level of information from it. In addition, there are ethical issues. We might have to target policies at different fine population groups. And there's a question of what would we do if we have, in a sense, too much information? So if we knew enough, this is like an imaginary future, but it's been discussed already, that actually we knew enough that somebody with a particular genetic makeup made them more predisposed to have a traffic accident. Do we somehow behave differently for that person? Mayor Schoenberger wrote a very nice paper about the whole system of insurance that our lives are based on. And he described it, I like this expression very much, human solidarity based on ignorance, which means that the whole insurance industry is based on the fact that we don't really know precisely the risks that everybody has. If we start to know those risks too precisely, the whole system breaks down. So having too much information could be a problem. I think another issue that could happen in the future is the issue of data storage. We assume that data can always be stored and recovered whenever, but cloud storage has an energy usage. Eventually, it will have some sort of capacity. When we can see in the past, when many technologies have started, such as the motor car, it seemed that there's a belief there'd be never any constraint on capacity. But this will be reached at some stage. And then we might have to be more selective about which data we store and which data we collect. Next slide, please. And as a result of these new kinds of data, we may also have to change the way we analyse the data itself. So a particular issue is the point of non-random sampling. So the data that we collect might not be a representative sample of all the individuals we're interested in. So if we're looking at mobile phone data, we're not understanding people who don't have access to a mobile phone, for example, and these might not be typical of those who do. So there might be a need for what I'm calling small data, traditional data sources to help us better understand the big data and to understand the limitations of it in terms of unobserved elements or individuals. The transport analysis might also put a greater focus on transferable understanding across different contexts. So can we understand things better across different contexts or cities? So is there spatially or temporal transferability in it? We can see this work in the subject of complexity science, which has been using a lot of these kinds of data to search for universal laws on how cities might behave. There may be more cross uses of data, even for conventional modelling techniques. So we might see more use of so-called engineering data to calibrate behavioural models and vice versa. And kind of somewhat obviously, I think we're going to see, as we've seen already, greater use of techniques such as machine learning and data analytics to gain new insights into critical elements, so elements that we might want to actually target in the future. Next slide, please. So as well as how our analysis changes, the actual real transport systems are also going to change. And because of this, our models and our policies need to account for this real change. So providers of transport systems, whether they be public transport companies or road authorities, increasingly using real-time information, possibly from competing providers of that information, And this will affect the way people travel. So, for example, if we predict an incident occurring, travellers may therefore become more aware of unreliable routes and reliable elements of the system, and so may factor it into their typical behaviour. So the way we're analysing the system and the way we're providing information actually affects the real behaviour. As another side to this, as we see there are many providers of information, there's also maybe a difficulty in coordinating information and control policies. So we could have one information provider, say, I'm not saying any names, but imagine a map, a real-time travel information provider providing one sort of information that influences you to do one thing, and then a control system predicting you'll do something different, and there being a mismatch. Okay, next slide, please. The next question I'm going to look at is how might predictive transport modelling change as a result. So by predictive modelling, I'm talking about models that take into account policy or future exogenous changes, rather than models that are just trying to analyse what happened in the past. The presumption would be that it'll become more empirically based, it'll become based more on evidence from data. On the other hand, more data means we can test theories more easily. And I think this could be a really big aspect of making sense of big data that can sometimes be overwhelming in its scale. We might become less obsessed, less keen on idealizations in transport that we use very commonly, such as concepts such as equilibrium, the idea of the economic man, gravity models, value of time. So these core ideas that we've come to base our whole knowledge on, we might think, well, are they actually necessary? There could be alternatives that are more easily found. I think particularly the fourth point is an interesting one, where the way both the way we develop predictive models and also the way we plan could change, because we have the potential now not just to focus on periods where systems are stable, but we can also possibly focus more on transient situations where there are periods of change going on. And we can possibly better understand drivers of change if we look at longitudinal effects. Over time, we should be able to, by this way, possibly understand the influence of more factors, including longer term and factors that are difficult to quantify. Okay, next slide, please. I've lost track of which question this is, but this is one of the latter questions. How might transport planning itself change as a result? So there might be a great expectation of planning for more specific situations. So we might have policies that could differ by even day of the week or the season or based on the weather, because now we have the understanding of how behaviour and how the transport system varies in those different contexts. Because now we have the ability to detect unexpected changes, the planning itself could be more contingent. So what I mean by that is that the plans would say, if this happens, we will do this. If this other thing happens, we'll do something else. So planning itself could be based on actually how to respond to unexpected future events. We have, in principle, the potential for more trial and error approaches, because we have this continuous feedback from data. So we could try out a policy and see what it does and get more evidence. I think a particularly interesting aspect, which is something we've just written a paper on, is the idea of ex post studies. So actually you can study after the fact whether a policy was successful or not. often this is avoided because it's believed that it could be threatening to the organisation that's decided to put in the planning measure. And as well as this, I think the way we might see more and more visualization of data. I think this is a common thing that we're seeing now, with the data being more to do with tracking, more intense, greater volume. This fits well with the idea of visualizing data. And this fits well with the move towards bringing greater public participation into transport planning. Next slide, please. Okay, so I'm going to finish the presentation with just 2 slides on each one, but I've got 3 applications that I think give some illustration of some of the techniques that I've talked about, some of the future or recent research issues. These are 3 pieces of work that I've been involved with, and I'm going to just briefly give you the idea of what they were trying to do and what I think was like distinctive about them related to what I've just been discussing. So the first application, we looked at 2 years of continuous detector data. Actually, we just looked at one location. We looked at several locations, but this is just about one location. So we just have a traffic detector, but we go back in time, a very long time. So this idea of continuous monitoring is coming up. And what the graph shows is the traffic flow on the vertical axis against time of day on the horizontal axis. So 24 hours is shown on the horizontal axis. So we see the 2 peaks, morning and evening peak in the traffic flow. Not surprising. So what we looked at is how to better estimate the mean profiles for different days of the week. So these 5 graphs are quite similar, but there are some differences, and these are significant differences we managed to show, can be seen in the data. To do this, we applied a new technique which we wouldn't have considered applying before without this volume of data, called functional data analysis, relatively newly developed technique. Next slide, please. And what does this mean? Well, even though the differences between the data seem quite small, if we write confidence intervals, so this example looks at Thursday against Friday, if we add on the confidence intervals, perhaps you can just about see on that zoomed in part, there are actually significant differences. So even though the profiles will look quite similar, we've got enough knowledge to say, well, actually, there are systematic differences between Thursdays and Fridays that we can detect in terms of when the peak period occurs. That potentially allows us to tune our traffic control policy measures or our policies to be day specific. So actual real life transport could change as a result. Next slide, please. So my second application was looking at Bluetooth data. So we had Bluetooth data across a city. We picked some of the data. This is from 23 detectors. We looked at the whole of 1 year, it was 2015, which gave us 7.5 million trips, and which we estimated to be equivalent to about 300,000 travellers travelling through our method we analysed. So the first thing we did was identify different spatial clusters, so where people were travelling from and to, generally speaking. And then from that, we analysed, we estimated sequences through the detectors by a technique called sequence alignment. Again, it was a technique originally developed for DNA sequencing, which we then applied into transport. So for the detectors that are shown on the map, A, B, G, M, N, S, T, you can actually see there are different routes through these detectors depending on whether you're detected at all of them, so you're not 100% sure to be detected, or whether you actually pass the detectors. And the sequences on the right are the 15 most common sequences that we estimated from the data. Next slide, please. We then used that to actually understand more about how people travelled across different days. So how repeatable were journeys? I think transport commonly we imagine to be very repeatable thing that happens the same every day. But I think certainly in this last year and a half, we've understood actually things can change very quickly. And I imagine in the future, we might have a situation where we're less repeatable in our journeys. Perhaps we make journeys less commonly to work. We mix home working with face-to-face working. So in this data, going back to 2015, we managed to identify different subclasses of traveller based on how often they travelled, their trip frequency, both in terms of their spatial variability, how much they varied the places that they went from and to, and how much they varied in their time of day. So from this, we were able to identify several different classes of traveller, which could be used in future predictive models if we were trying to target policies about encouraging people to perhaps travel less frequently, to work more at home, for example. So I think this has a particular relevance to the COVID situation that we've just gone through. Okay, next slide, please. The third and final application is quite a different one. This was from GPS data that was collected in Copenhagen, in fact, and from nearly 17,000 GPS traces, we analysed how people chose routes based on what the route they chose against what was the best route they could have chosen. So what's on the horizontal axis, we call it relative route cost. So we compare the travel cost of the route that was chosen with the travel cost of the best route for their journey based on where they went from and to. So a relative route cost of 1 means that they chose the best route. A relative route cost of 2 means they chose a route that was twice as costly as the minimum cost route. So what we see, not surprisingly, is not everybody's able to choose the best route, because situations are unpredictable, but there's a kind of bound where it kind of seems to cut off. So we were trying to understand, okay, if we could use this data, this new kind of data, to estimate new kinds of models. So we developed a new kind of network model to actually use this data. Next slide, please. This is a very brief description of what we came up with. So this is a new kind of network equilibrium model for estimating how networks, how flows travel through networks. The traditional model is the so-called UE, user equilibrium model. And if we look at one particular origin to destination movement going from the top left to the middle of the right-hand side, so we look at the left-hand panel, the traditional user equilibrium model would predict just one route was used by travellers. There was another traditional model called the logic SUE model, and that predict all routes were used, but in different amounts. But our new model, bounded model, we were able to estimate it of just a subset of routes that were used. And we were only able to estimate this because of the new kinds of data that were available. So this data made us develop a new kind of model, and then we were able to estimate the model based on that data. Okay, next slide, please. This is my closing slide. So I think the message I want to give across is actually we need to think more when we're thinking about big data than how it can help us pursue existing approaches. I've seen many papers where people have looked at, okay, how can we use big data to get an OD matrix? Or how can we use it to correlate trip rates against trip lengths? So very, very traditional things that we could have done 30, 40 years ago, but we didn't quite have, the data is just more easily available. But I think we have to think beyond that. I don't think we really get the benefit of it without thinking of how we adapt both models and planning. So I think these three things all need to move together. The idea of my diagram was that one wheel moves and the other wheels need to move as well. So I think to get the real potential from big data, we need to do everything. We need to rethink how we do modeling, how we do planning, and then we really unlock the potential for these new kinds of data for transport policy making. Okay, and the last two slides, I just list the references. I think these slides are going to be shared somewhere, so if you want to follow up anything that I've talked about. Okay, thank you.
Professor Watling, for your speech. Ladies and gentlemen, you can ask your question. I'm sorry. Let's give applause for Professor Watling. Ladies and gentlemen, if you can ask your question through chat message and mention to whose speakers you want to ask. Now, for our next speaker, Professor Silvio Ranise. He is the director of the Center for Cybersecurity at Fondazione Bruno Kessler and professor at Department of Mathematics, University of Trento, Italy. Some of his expertise areas are cybersecurity, AI, computer algorithm, SAT, and SMT. He got numerous projects and publications on this area. Let's meet Professor Ranise. Hello, Professor. Are you ready?
Yes, I am. Thanks a lot for the introduction and the invitation, of course. I will try to share my slides.
Okay. Ladies and
okay, can you see?
Yes, we can see.
Okay. Okay, good. So, what I'm going to talk about is search problems and search algorithms, basically. So, it's somehow related also to what Professor Watling discussed before in a complementary way, in the sense that it's relevant also, these kind of problems are relevant also for transportation, in which you, for example, search for the best route to go somewhere, or other planning issues that can be derived from the analysis of data, etc. But what I'm really focusing here in this talk is the search problem in abstract terms and some alternative techniques to the traditional way of solving search problems that is based on graph searching, which is a typical techniques in, for example, AI and other computer science applications. So I'm going to argue that there is a better way or an alternative way that should be part of the toolbox of engineers, because search problems are ubiquitous and go beyond the realm of computer science and transfer to other disciplines as well in engineering. So this alternative way is based on the use of automated reasoning tools called constraint solver or SAT solver or SMT solvers that are kind of classes of constraint solvers and are a way of solving these search problems in a lazier way. We will see how and why I call it a lazy way. So what is a search problem? Let's start from something which is related to transportation. One of the classical search problems is really the traveling salesman's problem. You are given a list of cities and the poor guy should go visit all these cities and return to the original city, okay? So what is the problem here is that you add more cities and the problem becomes computationally more heavy and more difficult to solve. Also, if you attach weights to the edges that connect the various cities, for example, having the distance between the two cities, or if you have to pay some kind of let's say fee for traveling on a certain routes, outer routes, etc., highways and so on and so forth, so then you can even come up with a refined version of the problem, which is an optimization problem. Okay.
Excuse me, Professor
Now,
Manise. Excuse me.
yes.
I
Yes.
think the slide doesn't work. It doesn't. We can only see half of the presentation. Maybe can you reset it and preview from the beginning? Yeah. Okay, we can see it now. Yes.
Oh, okay.
It's good.
Okay, so no problem. Sorry for this. I didn't realize that. So anyway, so the traveling salesman's problem is one, as I said, is one of the prototypical problem in search. You are given a list of cities. Then the salesman should visit all of them, possibly with the shortest route, and go back to the original city. This is one of the typical problems. This is connected also to an optimization problem, can be refined to an optimization problem. For example, if you attach to the connecting cities a weight, for example, the distance between the two cities. Of course, here the problem is that computationally the problem becomes more and more difficult by adding more cities to travel through. Another problem is for example, is puzzles. Okay, mathematical puzzles. For example, here is a simple example in which you have n queens, and you should put on the board without and find a configuration in which they are non-attacking. Okay, so no queens should be able to attack any other queens that are placed on the board. Okay, so while in the first problem you are interested in finding and establishing exactly the path and the single steps that lead to the solution of the problem, here you are not really interested in the steps that build up, that combined gives you the desired final configuration. Rather, you are interested in the final configuration. So these are two kind of typical problems, but search problems, as I said at the beginning, are ubiquitous and can be found, for example, in hardware verification or design, for example, VLSI placement for optimizing the surfaces or of for example, CPUs, etc. In software verification for debugging programs, for performing some kind of symbolic testing and the symbolic execution, in planning, as I said before, even in security, okay, by modeling both the system and the attacker capabilities, you are, for example, able to discover if an attacker can breach your system, for example, can breach a cryptographic protocols by playing around with, for example, intercepting messages, forging messages, etc. And even in robotics, if you want, for example, a mechanic arm to perform some kind of actions, then again, you can express this as a search problem. So in general, a search problem is made up of two things. One is the search space. So it's the set of possible solutions from which you want to extract the solution that you are interested in, basically, okay? In the example before, it's the routes between the cities, for the traveling salesmen, the configurations, the non-attacking configuration for the n queens problems, and then also a goal condition. Yes, is there a problem? No? Okay. So the other ingredient is the goal conditions. So the features that characterize what is a solution among the set of possible solutions, of all the possible configurations that you are evaluating, you are considering in order to identify what is the solution to your problem. So it's the set of paths between cities in the traveling salesmen and the non-attacking configurations in the n-queens problems. So how traditionally these kind of problems are solved? Well, you come up with a graph representation. Okay, the traveling salesman is intuitive. You use an edge for connecting cities, and cities are the vertices of the graph. And then you travel by using a breadth first search, depth first search, these kind of graph searching algorithms that are classical in computer science. And you try to solve the problems as an efficient way as possible, which is not always possible in theory, as complexity theory shows, because these problems are of a class called NP complete problems, which are computationally hard to solve. There is no polynomial algorithms that allows to solve these kind of problems. Similarly, for the n-queens problem, you can come up with a graph, in this case a tree, that represented the possible configuration of the queens on the board. You start from an empty board, and you start adding, for example, a queen from the left in the leftmost column, and you keep adding in the leftmost column that is free of queens, a queen, and then you stop as soon as you put it in a place where it is attacking. This cannot be furtherly expanded. Similarly, instead, this is a good one because these two queens are non-attacking, and you go on with a new one, etc., and so forth, and you expand. So basically, these are the idea underlying graph search algorithms. Okay, so you have an initial state, okay, that describe the initial configuration. For example, here the initial state is this, the empty chessboard, and in the traveling salesman should be the initial cities from where the salesman starts his journey, and the list of visited cities that is empty at the beginning, for example. Okay. The operators are transform one state in another state. In this case, an operator is add a queen in the leftmost free column, and transform this empty chessboard into this one where only the first cell is occupied. And then you have a goal condition, a predicate that describes which is the target state, the desired solution. So for the n-queens problem is a non-attacking state. So by having this and this kind of description, which gives you an implicit description of the search space that can be even infinite, okay, a search space. It's not necessarily finite, okay? Then you can organize and use a template, so to speak, algorithm to solve the problems, okay? And that this template algorithm, which is a graph searching problems, start from the initial node that describes the initial state, and apply operators to create a new states, okay? So this kind of algorithm identifies a frontiers state where that divides, basically splits into the set of nodes in the graph. One is the set of nodes that have been already explored, and those that are still to be explored. Okay, here the point and the efficiency in practice of this algorithm resides in the selection of the most appropriate search strategy to which next node in the frontiers to expand. Okay, so the idea is that you can solve these kind of problems using these template algorithms. Okay, and per instance, for every new instance of this problem, you have to come up with the right idea of the search strategy that allows you to pick one of the nodes in the frontiers in order to, let's say, have in practice, select the good ones, the good candidates that allows you to find a solution to your search problem in a very quick way, okay? In principle, most of these problems are incomplete. So in the worst case, the computational complexity is very heavy, but in practice, many instances can be solved by finding the appropriate and clever search strategy, so to speak, okay? Of course, it's still a lot of work to do to make this template algorithms work, because you have to select how to decide which data structures to use in order to implement your states, so the node graph, and the operators in order to implement this graph searching. And most importantly, the most important part is to have, besides the right search strategy, to be sure that your implementation satisfies some crucial properties like completeness. So not missing the solution, if it exists, is very important, okay? Or you can even have issues of optimality. For example, in the refined version of the traveling salesman's problem, you can, for example, consider weights attached to the arcs connecting the cities. And so you can ask yourself, does the solution that I have found is optimal or not? Okay, and so on. And of course, the complexity that I have said in practice depends, in many instances, depends on the search strategy. So the point here is that this is a lot of work, even if we have this template algorithm that allows us to solve, and this framework that allows us to solve the problem, is a lot of work for each problem instance. So what I'm asking is there a lazy way to do this, or a lighter weight way to solve this? Well, I would say yes. And this is the most important part of this talk, and is about use of logic to solve search problem. So the starting point is this observation by one of the professors that was teaching in Stanford, Zohar Manna, that the logic is the calculus of computer science. So this means that logic provides tools that allows to describe and even manipulate, okay, computational objects, like those that we have found, that we have defined in search problems, like states, like operators, like predicates on to characterize initial states and the target states and goal state, and so on and so forth. These tools are formulae that allows you to describe these computational objects, and even problems that can be used to encode the search problem, the original search problem, as a logical problem, so that this enables the usage of so-called constraint solver, okay? So you take the original search problem, you translate this into a logical problem, and then there are automated tools. Automated means push button that takes the logical representation of the search problem and returns a solution to the logical problem, okay? So in a push button way, in an automated way, even though the computational complexity of these problems is very high, is NP complete, as I said before, in most cases, or even worse, in practice, these constraint solvers are so well engineered because of years of engineering practice and years of refining strategies that allows for the solution of complex and hard and difficult instances of logical problems, that they are very efficient in practice. Okay, so instead of coding things, basically you have to encode things. Okay, so transform from the original search problem to a logical problem, use these tools. And of course, you have to go back somehow and map the logical solution that the constraint solver returns to the original description of the problems. But this is typically much easier to do. So let's see what does it mean really? Logic is the calculus of computer science on a simple example. Okay, so take the n-quints problems that we have considered, and when n is equal to 4. Okay, so how we use logic in order to describe this? So, well, the point is we need to select a way to represent by a logical formula a possible configuration of all the possible configuration that consist of putting 4 queens on the chessboard, and then define formula that identifies among all possible configurations those that are not attacking. So the idea here is relatively simple. You use Boolean Boolean variables, so one per each cell in the board. Okay, so for example, you identify this in the top left corner as x0, y0. Okay, this as x0, y1, up to, sorry, this is a mistake, it should be x4, x3, y3, etc. Okay, and then the meaning of this is that this Boolean, for example, this Boolean variable should be assigned to false because there is no queen here placed in this cell. Instead, this one should be assigned to true because this cell is occupied by a queen. Okay, so this is the basic idea. Then we need to elaborate on a description of how the configuration is non-attacking. So first of all, we need to say that at least one queen should be placed per line, okay? Because we need at least 4 queens placed on the chessboard, okay? This is the basic requirement. Then we can go on and we can say that we can express by logical formula that 2 queens should not be on the same line. Okay, so this basically considers the fact that, for example, the conjunction of 2 cells, okay, per line should not be at the same time assigned to true. The Boolean variables that represent the fact that a queen is placed in that position or not. Okay. Similarly, we should do the same for columns. Okay. And then we should also require this on the diagonals of the checkboards. This basically represents the fact that the queens can move arbitrarily, horizontally, vertical, and in diagonal on the chessboard. Okay, so by collecting all these constraints, then we can feed all this formula that represent the constraint to the constraint solver. Okay, and then the constraint solver will return what? We return an assignment to the Boolean variables. In this case, the Boolean variables is assigned to true are only 4. This is as intended. Only 4 queens should be placed on the board, and all the others variables should be assigned to false. Okay, so at this point, all we need to do is to map back by decoding this formula into the original set, into the original representation of the search problem, and realize that this assignment really represents this particular configuration of the board in which the queens are placed in these 4 particular cells on the boards. Okay, so the point here is that you need to come up with an encoding of the original problem, search problem, by using formula that represents the constraint on the set of possible solutions that describe the desired features of one of your solutions. And then here, the constraint solver will return you with an assignment that represents a particular solution. And so you need to decode and map back this solution to the original representation. Okay, so these are the main ideas. If you put everything together, basically the schema for solving search problem is the following. You start with the original search problem, you perform an encoding into a logical problem, you obtain a logical representation of the search problem, you feed this to a constraint solver that returns, that solves a satisfiability problem, okay? A so-called satisfiability problem, meaning that the formula that describe the logical problem that represents the constraint on the solution are true, evaluates to true, are satisfiable if the variables are assigned certain truth values, okay? So with the assignment to the variables that represent the solution, you should decode this assignment to variables and build and return an appropriate solution to the search problems in terms of the original problems, okay? Or the original description of the problem. So one of the advantages, or one of the main, if not the main advantages of this way of proceeding is that the hard work is put on the constraint solver. Searching for a solution in the logical space is delegated completely to the constraint solver, okay? So what you need to work on is this part, encoding and decoding. But typically, these are easier to do, okay, to come up with rather than coding a representation of the states and the operator in order to use the template graph algorithm that you have seen in the first part of the presentation. Most importantly, the constraint solver allows you to basically forget about all the nitty-gritty details about the search space and how efficiently, in practice, to look for candidate solutions, okay? This part is completely abstracted away and pushed in the backend in a sort of black box that you don't care about, okay? All you need to do is to know how to encode and decode as logical problems, your search problems, basically, okay? This is one of the advantages. So besides this, the fact that if tomorrow a new and more efficient constraint solver becomes available, then you can really plug in this new constraint solver in the backend that solves exactly the same problem, but with clever and more sophisticated heuristics for you in order to speed up your way of solving the search problem. This is particularly true after the SAT and the SMT solvers that are particular classes of constraint solver are basically have proposed standardized input and output languages for these tools, okay? Additionally, arguing the correctness, okay, of the encoding and decoding is typically easier than what you have to face in terms of hard work when you use the graph searching algorithm approach in order to solve this, okay? So far, in this talk, I have only scratched the surface and used Boolean logic. But the logic is much broader. And in particular, you have a very broad class, which is first order logic, okay? In which you can describe in a more sophisticated way problems. But there is a trade-off between these, basically, things, in the sense that the more expressive the logic that you use, okay, the less likely it is to be automated, or at least the computational complexity of solving satisfiability problem or logical problem in these fragments of first order logic becomes more and more complex, okay? So it becomes even harder or more difficult or even semi-decidable or undecidable. So there is no push button algorithm that allows you to solve satisfiability problem, the more expressive the logic you use is. Of course, the more expressing the logic, the more natural and easy becomes the encoding and the decoding. So here is the trade-off in this new way of solving search algorithm. You should become aware of which kind of logic you need, logic fragment you need in order to strike the best possible trade-off between having an obvious and natural encoding and decoding phase on the one end, so that it's easy to argue their correctness and completeness, but on the other end, you should not put too much of a burden from a computational point of view on the constraint solver. So you need to become aware of this trade-off in order to solve this kind of problems in an effective way. So constraint solver, I kept saying that there are two classes. One is SAT solvers, and the other are called satisfiability modulo theory solver that extend the SAT solver to fragments of more expressive fragments of first order logic. More expressive fragment of first order logic are, for example, linear arithmetic or integer linear arithmetic. So you have constraint, you can express a constraint like this: x plus y is equal to 3, and SMT solver will return assignment for these variables that are no more Boolean variables, but are integers variables. And for example, in this case, one possible assignment that will be returned is x is equal to 1 and y is equal to 2. Again, you have a trade-off between the efficiency and the easiness, so to speak, in which you can express encoding and decoding, okay? So if you want to have a broader and more detail, more overview and more details about this kind of solvers, I reported here 2 links to the initiatives that and the let's say websites around that list possible solvers to be used in this context. So applications, as I said, are manifold. I just mentioned 2 here, and model checking, software model checking is a particular technique that allows you to explore the search space, even infinite search space of programs, for example, in order to detect possible problems, or protocols. For example, in this case here, you have protocols that handle the critical region, entering critical region for processes using shared resources. So you should not be able to print at the same time 2 files on the same shared printers, okay? There are particular protocols that are mutual exclusion protocols that are subtle protocols to get correct that can be verified encoding the possible execution of the protocols and check if they satisfy the fact that at any state, no two processes can use the same shared resource. Another application is in security, and for example, is the analysis of access control policies. Access control policies are one of the basic mechanisms used to secure systems. Okay, they tend to grow over time, very large, very complex, etc. The risk of inserting inconsistencies or contradictions or redundancy, etc., is very high. So an assistance by an automated tool in order to detect such kind of inconsistency and redundancy is very important to ensure that access control policies are correctly defined and returns the result that are expected. Okay, so let me conclude, okay, and say that so the focus on using this lazy approach to solving search problems focus on the encoding and decoding that allows simpler automation and proof of correctness in many cases, allows you to abstract away from the nitty-gritty details of the search space that is completely delegated to the constraint solver. So what this buys you, we have talked about a lot of laziness, and we can summarize it as you are not expected to do nothing in this lazy approach, but you, for sure, you would be relieved of much of the work of implementing, deciding the data structure, implementing the right strategy, etc., for states, for representing states, for selecting operators, and that in order to build the state space, as in the case of graph searching algorithm. You are in between, okay? You should be aware of the fact that encoding and decoding are different activities, more conceptual and less, let's say, connected to coding, okay? So on a more serious variant of the takeaway message is the following. So we can summarize it as thinking a little bit more and doing a little bit less is in some cases could be an advantage to solve a search problem, meaning that encoding and decoding are more related to the conceptualization of the set of possible solutions, of the actions of the operators that transform one state to another state, and so on and so forth, in a logical way. Okay, so it's more a way of representing the search space rather than connected in the operational details, as it is the graph searching algorithm that I have illustrated in the first part of the presentation. Okay, so this should be something that you keep in mind when you need to solve a search problem and become, and this new technique, this lazy approach to solve problems based on constraint solving should be part, basically should become part, this is my suggestion, at least with this talk, of your engineering toolbox. Okay, it's another technique that could be very useful for managing complex and difficult problems. Okay. Okay, the last couple of slides are pointers for further readings. These are by no means exhaustive, and of course are biased by what I know more, which is my own work in this kind of field, and basically allows you, gives you an introduction on the use of logic in computer science, in particular, the use of the history of SMT solving as an extension of SAT solving, and two applications. One, infinite state model checking, for example, the case of the mutual exclusion protocol that I mentioned before, and also application of the to security analysis of access control policies that I briefly mentioned before. Thanks a lot for your attention. And once more, thanks a lot for the kind invitation.
Give applause for him, ladies and gentlemen. Now, if you want to ask questions to either of the speaker, please write on the chat message. Maybe I will ask Professor Ranise about the lazy approach. What is the example of the implementation of the approach in daily application? I mean, in Europe or specifically in your research, have they implicated in daily activities, in daily application?
Yes, for example, at Microsoft, they have been developing a tool called Z-Free, which is an SMT solver. It's a very efficient constraint solver, if not the most efficient one. And they use it, and they have integrated in several program analysis tools in order to improve the efficiency of and the quality of the code that they produce. Okay. So it's used in several different contexts, like program analysis, software testing, validation of high-level models based on UML, or also in some kind of application, for example, concerning security policy analysis, that using a language that they have developed, even cryptographic protocols analysis. They have developed something in collaboration with the French Institute in Riyadh also. So they are quite heavily used. Another context in which they are used heavily, SMT solvers and SAT solvers, most likely more SAT solvers than SMT solvers, is hardware verification. Intel, AMD, and other big players in the microprocessor game, they use this daily to check several aspects of their designs. In particular, they perform equivalence checking. So they perform a lot of optimization on integrated circuit in order to minimize the surface or the energy consumption, etc. Of course, these transformed designs should be proved equivalent to the original, so to speak, designs, in the sense that if you have another, you can optimize it a lot, but it should, in the end, it should perform addition between a sequence of bits. Okay, so they use it in order. They have a high-level specification, which is very poorly. It's not optimized in any way, and they have this very optimized version of the same adder, and they wanted to check that they produce the same result. And they encode this as a SAT problem, and they use it, and they use a SAT solver for this. So these are example. And more mundane example is planning. For example, basket games in Spain are produced, the calendar of the basket games in Spain are produced by using this SMT solving technology. There are many others. Yeah.
Okay, thank you so much. Is there any question?
I
From
see one
participant?
in the chat. I'm interested in verifying a software model. Maybe a lot of developers make code without a model or try it out. The problem is that the model is fixed before the developers start coding. Can I use SMT Solid to solve the problem? It would be great if you provided a description of the verification if the developers start coding. Okay. Of course, you have, okay, probably if I understood correctly, the question is that you have a high level description of the system or the software program, and then you have a bunch of programmers that contributes code and implement what is supposed to be the real working version of the program. And then you are left with, okay, with the question, okay, is this final piece of code equivalent or does the same job of the high-level description? I believe that this is the question. If this is the question, I'm afraid that the answer to the question is negative, in the sense that in principle the verification problem is of course undecidable for arbitrary problems as the one that is stated here. So this means that there is no available push button tools that allows you to describe the problem and this kind of problem and solve it in an automated way. Okay. This derives from several well-known computer science, fundamental computer science problems related to determination, the halting problem, basically, of general algorithms. What you can hope for is identifying selected properties that are much simpler for to prove, okay, and use this kind of solver in order to check that these properties are satisfied. So the point is that you have, by checking these simpler properties, you augment the trust, your trust in the fact that the program does exactly what it's supposed to do, okay? But in general, the verification problem cannot be solved, especially for modern modern software system that have dependencies on third-party libraries, APIs, etc., relies on complex infrastructure, and so on and so forth. It's almost impossible to describe completely in a formal way all the details that are required in order to describe precisely the implementation, the working system, and come up with an automated solution to your verification problems. I'm sorry to say this, but there are inherent limits. You can do something in order to improve your trust in the system by considering simpler problems and simpler properties. Okay.
Very much. I'm sorry, but our time has up. If any participant also have question, you can contact the committee and they will forward the question to the speakers. We'd like to thank you for the participant and send our gratitude to the keynote speakers. It's been a very interesting speech. We hope this session could rise up our knowledge and experience. So good morning for our speakers in Europe And good afternoon, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh.
Thanks a lot. Bye-bye.
Bye. Thank you.
Thank you for all the keynote speakers for the insightful keynote speech. The certificates are awarded to keynote speakers in the second panel session. Dr. Insinyur Heru Dewanto, STMSC Engineering, Institution of Engineer, Indonesia. Professor David P. Watling from University of Leeds, UK. Professor Silvio Ranise from Fondazione Bruno Kessler, Italia. Ladies and gentlemen, we are now going to listen to the closing speech delivered by the chair of the committee, Mr. Rianto, PhD. In addition to that, we are requesting the chair of the committee to announce the award of the International Conference on Engineering, Technology, and Innovative Resources 2021. Ladies and gentlemen, please welcome Mr. Rianto, PhD.
It begins from Kalibrantas expansion project in East Java, Indonesia. Since 1980, history justified that PT Brantas Abipraya were the first BUMN Karya that officially created by Indonesia government. Since that day, we were being inseparable part from Indonesia development. We learned, growing and transforming become the living company that surely proven can step up and facing the challenge. Well known with the holistic services construction company, which capable handling national strategic projects, currently PT Brantas Abipraya supported with 7 business units and 1 subsidiary that are productively and independently strengthen PT Brantas Abipraya position as one of the best construction company in the market. Abipraya Sumber Daya Air. Abipraya Gedung. Abipraya Infrastruktur. Abipraya Beton. Abipraya Alat. Abipraya Property. Abipraya Tol. And PT Brantas Energi. Abipraya, spirit for giving the best.
Thank you very much. Good evening, everybody. Thank you for the keynote speaker for the valuable sharing, and also for all presenters of this third ICETIR for your contribution to this conference. I believe that this conference will not occur without all of you. Finally, we will shortly come to the end of the conference, and I think this is usual and tradition in the scientific meeting that we selected one of you that we think you have done something very, very excellent. I know that all of you have done excellent works with all your expertise, and we can recognize it in your paper, but we are on duty to do this, not to distinguish or adjust which better and which is not, but this is only to give more motivation to all of you, because I think it is important to make improvement. We know where we are and we know where we want to go. So for one of you that are selected, so we select one best presenters for each parallel session, and we also select one best paper based on the reviewer recommendation, and I will announce the best presenter from room 1 to room 15. From the room 1, the organizer has selected a paper entitled Pattern Recognition of BIMA Handwriting using the Local Binary Pattern Feature Extraction Method and K-News Neighbor Classification Method, presented by Mustiari. Please applause for the best presenter. And from the second room, we have robust audio watermarking via quantization and particle swarm optimization, presented by Tariq Bayu Aji. Congratulations. And for the room 3, we have application of modular multi-level converter for a grid connected photovoltaic system, presented by Mr. Tin Ngoc Qua. I think this is from Canto University, Vietnam. So Canto is one of our co-organizers, so congratulations for Ms. Tin. And then in the room 4, we have validating an analytical method to predict flexural behavior of RCT beams retrofitted with bonded steel wire ropes in the negative moment region, presented by Yanuar Haryanto. And in room 5, we have corrosion rate of deteriorated steel bar protected by sacrificial anode cathodic protection, presented by Ms. Pinta Astuti. In room 6, we have land use planning and its impact to movement pattern in Purbalingga City, presented by Propo Hardini. Next to room 7, the paper entitled Analysis Factors of Personal Information Sharing in Online Job Portal Application, presented by Riko Wijayanto. In the room 8, we have NYZ, Nikah Yuk Company, a startup for your dream wedding, presented by Nadia Sari Akita. In room 9, we have performance evaluation of virtual machine and Docker for serving web application, presented by Hari Siswantoro. Next to room 10, we have layout optimization using the block band algorithm to minimize material handling costs on track 11, presented by Yulinda Ulfa. In the room 11, we have facility layout planning using craft method and group technology in manufacturing 10 tons vertical drawing machines, case study in PT Pura Barutama Unit Engineering Kudus, presented by Gufron Alvero Zawazaka. Next to the room 12, we have integration of Six Sigma, FMEA, and trees to improve product quality, upright piano case application, presented by Sri Indrawati. In room 13, we have geochemical data for geothermal exploration on Grau Sakti Jambi, Indonesia, presented by Hari Wiki Utama. In room 14, we have preliminary study on application of quadcopter for measuring ship NOx emission, presented by Trika Pitana. I think he is from ITS Surabaya. ITS also is one of our co-organizers. And the last room, room 15, we have crack growth behavior in air and hydrogen of iron 3% silicon single crystal thin sheet, presented by Yun Thanh Thuong. This is from Canto University, Vietnam. That's all of the best presenter, and we still have one more excellent paper. This is recommended by the reviewers and assessed by the organizer. And congratulations to Yuanda F. Pranata, Rita Magdalena, Nur Kumalasari, Kaisar Prativi. You are selected as the best paper with title Alzheimer's Disease Classification based on Magnetic Response Imaging (MRI) using efficient net architecture. So again, congratulations for all people to have contribution in this conference, and also for anyone that that are selected as the best presenter or best paper. I think you did a great job, excellent job that come together to this conference. And I think I will give some closing speech, right? Okay. Excellencies, keynote speakers, presenters, authors, organizers, all of you. Yeah, I would like to mention our 16 organizers, I think, if I remember correct, so we have Universitas Mataram from Mataram, we have Universitas Hasanuddin from Makassar, we have Universitas Jember from Jember, East Java, we have ITS, Surabaya, we have UNS from Surakarta, UGM, Jogja, we have Mula Warman from Samarinda, we have Palangkaraya, UPR, also we have Universitas Pertahanan and Universitas Indonesia, and also we have IITP, Purwokerto, and Universitas Amikom. Those are from Indonesia. Also we have 3 partners from abroad, which is Canto University from Vietnam, UTHM from Malaysia, and CRE from Taiwan. Thank you for collaborating in this conference organization, and I believe your contribution is significant to the successful of this conference. And also I believe that without you, all of speakers, all of presenters, this conference will never happen. Ladies and gentlemen, I would like to highlight something that I think engineers always put a footprint in every civilization, from the pyramid in Egypt to the Monas in Jakarta, to Eiffel in Paris, from the small car into aircraft, from visit to between 2 cities until travel to Mars. There is always engineer in that. So engineers plays a very vital role in the human civilization, and I believe we will do this always, and we will do this in the future. And that will not be possible without any research in engineering. And that is what we do as engineers. We do some research in engineering, and it will not possible without any research scientists in engineering, and that is who we are. We are scientists, we are researchers, and sometimes at one point we found that what we think could happen very long time after we thought and we found some innovation. This is because we need some industries to collaborate, to join the innovation to make some products. And we struggle very hard and for a long time to make collaboration between scientists and industries. And we still have more challenge to make collaboration between researchers. Yes, I think we can find good collaboration between scientists and industries in developed countries, but this is something that we still need to struggle in developing countries, especially in Indonesia. So I really hope that our togetherness in this conference during this today will not end at this time. Scientific meeting is not the end of everything. We still need more efforts to make what we think, what imagine, what we've done in research to be useful in real life. And I hope that all the governors, either in this plenary session or in parallel session, will open a gate for collaboration among us. And I, on behalf of the organizer from the Faculty of Engineering, University of Sudirman, we open our mind, we open our hand for any future collaboration in research in the future. And of course, we will extend the organization of this conference in the future with more organizers, more partners, to make more people come together to share their ideas and their research. So, ladies and gentlemen, thank you very much for your contribution in this conference. I hope we meet again next year in the same conference, ICETIR in the fourth ICETIR in 2022. Thank you very much. Good evening. Selamat sore. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much, Mr. Yanto, PhD, for inspiring closing speech.
Ladies and gentlemen, this is the end of the conference. We are appreciative to the keynote speakers who came from different countries and also for the conference participants. We hope International Conference on Engineering, Technology, and Innovative Researchers could gain and rise up our knowledge, experience, and exposure with respect to the engineering and technology science. Before we end this event, we want to deliver a message from editorial team. For all the participants who attend the parallel section, please submit the camera-ready file before September 8, 2021, so we can proceed to the next public stage. Thank you.
And thank you for all of the committee who organized these conferences from scratch and roughly, along with the sponsor who aid this conference through fundraising and so forth. And we offer our apologies for the shortcoming of this conference. Thank you and see you next year.
It begins from Kalibrantas expansion project in East Java, Indonesia. Since 1980, history justified that PT Brantas Abipraya were the first BUMN Karya that officially created by Indonesia government. Since that day, we were being inseparable part from Indonesia development. We learned, growing and transforming become the living company that surely proven can step up and facing the challenge. Well known with the holistic services construction company, which capable handling national strategic projects, currently PT Brantas Abipraya supported with 7 business units and 1 subsidiary that are productively and independently strengthen PT Brantas Abipraya position as one of the best construction company in the market. Abipraya Sumber Daya Air. Abipraya Gedung. Abipraya Infrastruktur. Abipraya Beton. Abipraya Alat. Abipraya Property. Abipraya Tol. at PT Brantas Energi. Abipraya, spirit for giving the best.